In our last video, we learned how gradient boosting builds individual trees. In this video, we'll learn how we control the power of each expert using a crucial safety knob called the learning rate. By the end of this video, you'll have an intuitive sense of how XGBoost uses this control to achieve its famously accurate and robust performance. Welcome to Scovia Labs, where we make AI concepts feel like everyday ideas. Let's look at a simple example where the training data consists of power consumed and the temperature. Our goal is to predict the power consumed based on temperature. To understand how XGBoost works with learning rate, let's look at how a tree trained on this dataset makes a prediction. Take the tree we just split. We'll call the model's prediction rule to be a function of x. That just means what number the model outputs for an input x. In our case, the function of x is to start with the baseline, where the mean is 8.8, and then send x down the tree to a leaf and read off that leaf's correction, and add that correction to the baseline. For our depth 2 tree, the leaf corrections are shown here, and you can see how it traverses this tree to calculate the final value. This calculation we went over is the no shrinkage version, where each tree's correction is added at full strength. Now, learning rate, which is also called shrinkage, and it's written as eta, is simply something that scales the correction before we add it. Think of it as a volume knob for each tree's contribution. Mathematically, using the same tree but with the shrinkage eta looks like the following. Note that we are essentially shrinking the contribution of every tree in correcting the prediction value. Depending on what the value of eta is, you may get slightly different values. And you see examples of what happens when eta is equal to 0.5 or equal to 0.2. So why do this? So it turns out that a smaller value of learning rate means smaller steps per tree, which is safer and less likely to overfit. You can think of eta as a volume knob on how loudly each tree speaks. Shrinkage doesn't change which split we pick in the current tree. We still choose splits by gain or sum of squared error reduction or similarity gain. Shrinkage is applied after the tree is built, when we add its leaf values to the model. Shrinkage changes the next round's residuals. With a smaller eta, our first tree only partially corrects the errors, so the residuals stay larger and clearer for the next tree to learn from. That's the slow and steady behavior that people like about XGBoost. We now have our first gradient boosting tree, and it uses the baseline 8.8 and 3 leaf corrections. With a learning rate of 0.5, each correction is added at half strength. Gradient boosting always works on the errors left by the current model, so we recompute the residuals after tree 1. And those become the training targets for tree 2. Residuals from the first tree are calculated by predicting the target for each sample by passing them through the first tree and then subtracting it from the true value. We'll follow the same recipe as before to construct our second tree. We test for different thresholds and select the best one for the root node. The difference is that we work on residuals that are calculated from the first tree. While constructing the first tree, we used residuals calculated from the average value. Here, we are using the residuals not from the average but from the first tree. one can construct multiple trees by targeting residuals of the previous tree. The learning rate is the safety control that ensures our model doesn't overcommit to the first few trees. When shrinkage is 1, each tree fully corrects the mistakes, which can lead to rapid overfitting. When the shrinkage is less than 1, each tree only partially corrects the mistakes, forcing the model to take smaller, more conservative steps. This makes the model more robust and generalizes better to new data. This powerful team of experts approach, carefully controlled by the learning rate, is one of the core components inside the XGBoost algorithm. Next, we'll cover the concepts of tree capacity and regularization in the upcoming video of this series. Thanks for joining us on Scovia Labs. Hit that subscribe button for more insights, and as always, stay curious.